We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Welcome students to the second video of the multi-protocol label switching. So in the first video we have seen why there is a need of multi-protocol label switching. So as all of you know that multi-protocol label switching first of all improves the network efficiency, not only in terms of the network throughput but also in terms of the quality of service. So let us today see how actually MPLS works in the MPLS domain. So what is the background of the multi-protocol label switching? So here we can see the multi-protocol label switching which itself works between layer 2 and layer 3, and that's why it is also referred as the layer 2.5 protocol. So here you can see it is integration of layer 2 and layer 3. It is a connection oriented forwarding mechanism over the layer 2. So in turn we are getting the advantage of flexibility and scalability of layer 3 routing. Interesting point is MPLS does not replace IP but it supplements IP. So it works in cooperation with IP. Traffic can be marked, classified and explicitly routed. So this is very important point because traffic can be marked, classified and explicitly routed. We will shortly see what is the meaning of this traffic can be marked, classified and explicitly routed. QoS can be achieved through MPLS. So already we have discussed in our earlier lecture that quality of service parameter that itself poses a big challenge over IP since it was the connectionless protocol, but here that can be achieved quite easily. So if we compare, the interesting point is now if we compare the IP and MPLS, then routing decisions in IP, so that was based on the destination IP address, and that destination IP address is masked at the routing devices, and it would be forwarded to the corresponding output interface of the router. But here this routing decision is entirely different, and the important word is label switching, and that word itself MPLS, multi-protocol label switching. So that is based on labels. In IP protocol we have the entire IP header is getting analyzed at each and every routing device point or we can say at every hop inside the network. Hop here refers as a router. While in MPLS label switching, which is performed only at ingress router, we will shortly say these are all the important words that which we will today see. So that is the ingress router. Another thing, support for unicast and multicast data. Now if you look at in terms of IP and MPLS, then in IP routing requires special multicast routing and forwarding algorithm. So already we have seen in our syllabus that how unicast routing algorithm works and how multicast routing algorithm works. Multicast routing itself a challenging task. So IP has a separate mechanism to deal with this multicast routing. But in MPLS, it's only about label switching, requires only one forwarding algorithm. So that is what, only one forwarding algorithm, no much more processing is happening over the IP datagram for routing that datagram. So that's why there is a significant amount of time saving which takes place in this mechanism. So before we move into the how actually MPLS works, we need to see certain keywords which is under the domain of the multi-protocol label switching. So first is MPLS, already we know. FEC, very important, this is the forwarding equivalence class. Then label edge router, label switching router, label information base, label switched path, and label distribution protocol. However, all these terms are important for you as part of syllabus, and not label information base is much more important, but label switch path is important term. Label distribution protocol, which is not in part of the syllabus, because that is even more detailed part. So let's look at this individual keyword. So forwarding equivalence class, FEC, what does it mean? It is a group of packets that requires the same forwarding treatment, or we can say same forwarding path across that chosen path. So important terminology, this group of packets that require same forwarding treatment. Same forwarding treatment, this word is important, same forwarding treatment. The reason is we will shortly see what is the meaning of that. Packets are grouped based on any one of the following. Now when we say forwarding treatment, so what could be the treatment? So it could be based on some address prefix, it could be based on some host address, or it could be based on some quality of service. So based on this parameters, the FEC will be labeled. So that's the very important key concept in working of the multi-protocol label switching. So again I repeat, group of packets that requires the same forwarding treatment. And what could be the example of same forwarding treatment? You make a group of IP addresses based on its address prefix, or you can say based on something like network address, or you can make a group based on the quality of service. And then you will assign, and then a label will be assigned. So let's see an example. So interesting example, now we can see we are having, these are the 4 different destination addresses which are required to be routed, okay, inside the MPLS domain. Now we are talking about only MPLS domain. So if we look at this address, then assume that 124.48.45.20, which is much more matching this address with this last address. The reason is why I'm looking this, because if you look at the first 2 octets of this IP address, which is destination address, are similar, and assuming that this prefix is now one of the parameter for assigning a label. So that means if this prefix is similar in this case, then we are giving the same label, and that is the label X. So here we have given label X for these 2 which are the similar. So this is one group I will assign, that is what 143.67. So 143.67, 2577 and 8422. So this is the label X, and rest of these 2 are also similar in terms of the first 2 octets. So that is the prefix line. So we are giving label Y. So this is what how we are labeling this destination address. In terms of another example, now we are not only dealing with address prefix, but instead we are dealing with also quality of service parameter. Now what types of quality of service parameters? Because this is very important in terms of when we want to support various types of applications over the network, and every application may demand the data rate in a different form or in different rate. So let us see this, where we have there are 5 destination addresses, and if you look at, now someone can think of just let's make a group of this QoS equal to 1. However, if we combine 2 things together, that is the address prefix, then here address prefix refers, in spite of they both require the quality of service parameter to be 1. So QoS is 1, and but address prefix is different. Let's look at another example. This is interesting. QoS is 3 and QoS is 3. QoS is 3 and look at the address 143.6784.22, 143.67.12.01. So here we can again look at that this two octets are similar in this case. So two octets are similar, and also the QoS parameter is similar. So we are putting in one label, common label. So look at this, we are given label C. So this label C has been assigned to 143.67 8422 143.67 12.01. So that has been assigned label, similar label. So why we have given that? Because now the here QoS is same and address prefix is also same. If you look at this QoS4, that is entirely separate destination address, 124.48 also having this another address which is having the same address prefix, but both differ in terms of quality of service parameter. Now quality of service parameter is much more emphasized rather than this address prefix. The reason is it itself clearly depicts that both this address destination require different types of service. When they require different types of service, it's better to have a different label, and that's what here 124.48.66.19 has been given different label, and 124.48 which requires QoS parameter 1 has been given different label. And similarly, the one thing which is left, that was QoS1 with the 143.67, so that has been assigned different label. So I think this would make it clear to you. So label edge router is can be ATM switch or any router. Now here there are two important words which we will face in label edge router. One is ingress and another one is egress. So ingress, LER performs the following steps, and that is what the receives the packet and stuffing the label and forwards the packet into the MPLS domain. So this is what the ingress, the packet is coming to the MPLS domain. And egress LER, that is egress label edge router, does the reverse task. That is what simply it would remove the label and delivers the packet to the router which is outside of the MPLS domain. Shortly you will get the idea of this. Label edge router, label switching router. So inside a router or switch that suppose MPLS. Edge router, that means MPLS domain. Whenever the packet enters MPLS domain, the first router which it encounters, that is the edge. And whenever packet exits the MPLS domains, so the router through which it exits, so that is again the egress edge router. And in intermediate, all the nodes which are nothing but example of label switching router, the router which is supporting MPLS protocol inside the MPLS domain. So that is what the label switching router. Label switch path, some of the very important terminology over here. LSP defines the path through LSR from ingress to egress. FEC is determined at the LER ingress, very important. So forward equivalence class mechanism will be defined at the LER egress, that is the label edge router ingress, because IP datagram has entered a MPLS domain. At the time there should be a provision of the predetermined path for that packet or for that flow to reach the egress edge MPLS router. So for that there must be established LSP, that is called label switch path. There must be LSP, label switch path, and if it does not exist, then it must be created at that time. But interesting part, it is unidirectional. So that means there is a clear-cut flow of the data from this end to this end. So it's not bidirectional. So there is a very clear-cut flow of data. So let's directly move to this MPLS operation. Quickly I will go through this. So this is one of the workstation. Maybe this is an example of peer-to-peer, or maybe one of the workstation which is inside of the LAN, and this is the router device. You can see this is the router device, which is a normal router, just like your IP for forwarding the IP datagram or for routing the IP datagram. This is a router, also you can say LAN switch, and this is a normal router. So this is a part of the, this machine is a part of the local area network. So packet is coming through this LAN switch or one kind of gateway and coming to this router, and then this router pushes this packet to this another router. But important thing, this another router is now MPLS domain router. So what we can say, label switch router. But another important functionality of this router is ingress edge router, ingress edge LSR, we can say ingress edge label switch router. So this has to take the responsibility for assigning a label over the established LSP, label switch path. So this is the label switch path. So whenever packet has come to this router, it would take only this route for that given quality of service. Remember this. So this is very important point. So for all that destination address of this machine and for given quality of service parameter, maybe 3 or 4 or like that, all the packets for that application data will flow over this path, not like conventional IP network that some of the data packet may take this route, some of the packet may take this route, or some of the packet may take this route. Not like that. Every packet inside that flow of the data for that given application will take this route. So important things, this was the ingress edge LSR, I will say, and this was the egress edge LSR. And what is their functionality? Quickly we will go through this. So you can already read this PPT, but some of the important points which I would like to highlight here. A packet enters an MPLS domain through an ingress edge LSR. So already we have seen in the diagram ingress edge LSR. So packet has entered to that ingress edge LSR, where it is processed to determine which network layer services it requires, defining its QoS. So very important, this is the QoS. So based on QoS, now ingress edge LSR has to assign the label for that given LSP. So the LSR assigns this packet to a particular FEC, so that is forwarding equivalence class, and therefore a particular LSP, so label switch path, and appends the appropriate label to this packet and forwards the packet. If no LSP yet exists for this given forward equivalence class, then edge LSR must cooperate with other LSRs in defining new LSP. So already that I have told during that discussion of the diagram. Now once it has pushed the this flow of data, or we can say datagram, inside the MPLS domain, then the datagram has come inside the MPLS domain. So that is the second phase. So we have three phases. The packet is arriving at ingress edge LSR, then it is inside the MPLS domain, and third phase it arrives at the egress edge LSR. So let's look at the second phase when it is inside that. So within the MPLS domain, and each LSR receives a labeled packet, removes the incoming label and attaches the appropriate outgoing label to the packet. So what is the task of the edge any LSR which is a part of MPLS domain? So we have three types of LSRs. Ingress LSR, that is at the entry point. Normal LSR, LSR means label switch router, and egress LSR. So whenever normal LSR receives this packet, it will simply remove the label of that datagram and attaches the new label, that is a new outgoing path for that LSP. So this does at second layer, it does not look at the third layer. So are you getting this point? So that's why no consumption of time, just remove the label and attaches the another label and forward it. Forwards the packet to the next LSR along the LSP. So no time would be taken in doing this. And finally the egress edge LSR, that is the egress edge label switching router strips the label, that means removes the label, because now it is the exit point. So it would remove the label and reads the IP packet header and forwards the packet to final destination. Very important point here. Now this is the only router which would read the IP packet header, and that is what the exit router. So here how this entire MPLS operation is getting carried out. I hope you might have got this. How does the MPLS? So MPLS works. So here I end this session. Thank you for listening.